Welcome back to our hierarchy of quadrilaterals. A quick review from where we've been. Started at the top with quadrilaterals, remembering quad means four, so it's a four-sided polygon with the sum of the interior angles being 360 degrees. Move on to a little more specific one, the trapezoid. A trapezoid has one pair of parallel sides. Now, a more specific trapezoid is the isosceles trapezoid. Isosceles meaning these two legs are congruent to each other and the common base angles are congruent. Because of that, we found that diagonals are congruent using that SAS property, and the adjacent angles not along the same base. So these two angles are supplementary. In addition, we have this wonderful note that the mid-segment, which is going to meet right in the middle of each of the legs, is parallel to the two bases and is actually equal to the base plus the base divided by 2. Top plus bottom divided by 2. More specific one is the parallelogram. Parallelogram, the opposite sides are both parallel and congruent, going across the shape in both directions. The opposite angles are congruent, those two and those two. All adjacent angles, sup, right? This angle says to this angle, sup. This one to this, sup, sup, sup. Diagonals bisect each other, which means they split them in half. So going from the edge to the middle, in both directions is equal. Here to here and here to here is congruent. Then we learned about our rhombus. Our rhombus is a very special parallelogram that has, yes, opposite sides parallel, but also all four sides are congruent. Not only that, we talked a lot about the diagonals. Our diagonals bisect the opposite angles, so not only are these two angles congruent, but all four parts of these are congruent because it's splitting each of these in half. In half, here and here. And the diagonals are meeting right in the middle, just like the parallelogram, and forming a right angle, making them a perpendicular bisector to each other. Final property, the diagonals form four right triangles. Since these are all right angles, we have 1, 2, 3, 4 right triangles formed. Going back up and over in the other direction, we're today going to learn about our rectangle. What's special about our rectangle? Well, again, we still have those opposite parallel sides. Right? The opposite sides are still congruent. So let's get more specific. Let's look at the angles, right? If we notice, on a rectangle, all our angles are right angles. So that's our first property. All angles are right angles. Second property, you can probably guess, has to do with those diagonals again. So our diagonals, cutting across the shape, are similar to those in our isosceles trapezoids, meaning that they are congruent to each other. This one is congruent to this one. So, our diagonals are congruent. And yes, it still does bisect. So, this part of the diagonal is congruent to that part. This part is congruent to that part. Same as in that parallelogram. But, not only that, the whole thing is congruent to each other. And I do have a quick little joke about our rectangle, and my joke goes, what did the sides of the rectangle say to the angles? You guys are all right. Get it? Because they're all right angles, so the sides. Okay. Anyway, another punny joke, but hopefully you're learning a lot about quadrilaterals, and we will meet up with you next time.